Zo. Heel goed. So, welcome everybody. Today we're gonna have some fun. Don't know heel goed. So, yep, we're live. Very good. Welcome to this live coding session. We're gonna do some fun things. We're gonna make a trivia game in Clojure and ClojureScript. Today we're gonna focus on setting up. We're gonna trying to get used to this. Live coding stopped working, so here we are. Okay, so I'm gonna build a trivia game in live coding sessions. I create the schedule. Today we will just set up our project and get to know some technologies. In particular Leiningen to build Clojure and ClojureScript and have some live reloading. We will use GitLab for project storage. We'll try to get the continuous integration working. And if there's some time, I'm aiming for about a session of 1 hour. We will use Docker and Docker Compose to create a continuous integration thing on your own environment. From these live sessions, I will create smaller videos which explain the project much more concisely. During the live coding, stuff will go wrong. I'll have to figure stuff out. So you're in for a ride there. All right. So let's get started. So for today, we'll start with Leiningen, GitLab, and Docker. First thing, Leiningen, it's a build system, right? I'm assuming you have some experience with Clojure, maybe not full projects, but with syntax and everything. So on your system, you should have at least Java, which you need, the JVM on which Clojure runs. And perhaps you already have Leiningen. Leiningen is a build system, basically much like Maven or Ant or Makefile. For other languages. I don't install Leiningen itself. I use a program called Homebrew, which is on my Mac, and it allows me to just install Leiningen and many other programs on my Mac in a safe way. So all you need to do is brew install Leiningen, and it will, well, I already have it, but it will go and fetch it and install it and maybe update it if necessary. Oh, look at that. It's updating. It says it's already installed, which is very good. It's a perfect piece of software. It allows you to create new projects based on templates, and it makes life very easy. I will not use templates. Excuse me. I will not use templates because I want to go through the entire process so you can see it, so you can get a feel for it, why it is needed, and why we do certain things. So I have this project folder. So there we go. Currently it has two things. We will create a new directory called trivia. Well, we'll call it trivia, why not? And it's empty. It's very empty. I'll put it more in the screen. So since we're going to make an application that contains both Clojure and ClojureScript, I like to use a common directory structure. If you have a really large project, you would separate the two and say I have a front-end project and back-end project, but that's not really relevant for now. Maybe if it gets really large, we can easily split it as long as there's no dependencies between the two. So for now, we'll make a source Clojure directory and a source ClojureScript directory. There's also movement to have a ClojureScript common format in which you both combine the Clojure and ClojureScript, which works really nice if you have a tightly integrated piece of software. For us, that's not really relevant. It's more of an advanced feature. And the project structure in this sense, it's already done. We need some resources as well for the ClojureScript files. It needs a HTML file, maybe some JavaScript files or libraries that we want to include. So we'll make a resource public. And that's basically it. If we then start to make a project, so we'll open up the file, go to projects, Clojure, we have our trivia set up, and we'll create project.clj, which is the Leiningen start file. Leiningen will use this and see what dependencies needs to get, everything that is needed to build it, and it does it by having a dev project. Let's call it trivia, and we'll put the version at 001 snapshot because we can, and everything that Leiningen needs is within this structure. This is also the only file that we need to make outside of our development environment, and with that I mean for Clojure development and ClojureScript development, I use the Cider library from Emacs. It's a really great system for integrated development, which is, it has everything from code completion to refactoring to interaction. Basically, everything you might ever need in Clojure development, Cider provides. But Cider needs a Clojure project to be running, a Leiningen project. So in order to do that, we have a project file, and in order to create a project file, we cannot use Cider, so we have no code completion, nothing. So at least it's very simple in the sense that you give it a description, maybe a URL. Well, I have my own website at www.buildfunthings.com on which I publish these videos. We'll skip the license part. Well, we'll do a license, why not? License, which one shall we take? We'll take a MIT or GPL v3. It's very permissive. We need a link for it. I'm cheating as I always can. As you never really edit a project file from scratch, I cheat and I have a working copy next to me. Dependencies, it takes a list of things that you depend on, and the most basic thing that you have is the Clojure and ClojureScript libraries, right? Those are the things that Leiningen needs or your project needs to run. So we'll add those. We'll add the Clojure library of 180, and pretty soon it will be 19, and the ClojureScript library of 19227, and the versions change so fast. It's insane. The speed of development in the Clojure community is insanely fast. So we'll have a plugins directive. These are plugins for Leiningen, so it allows you to enhance the build cycle with things like code coverage, which is really nice. having environment variables from the build system into your running system, database migrations, ClojureScript building, and that's one thing that we need, and that's the line ClojureScript build plugin. This allows us to to actually build ClojureScript code, and the ClojureScript code is basically Clojure formatted, Clojure syntax. Well, it's a Clojure for the for JavaScript, so it is a transcoder between Clojure and JavaScript. So from once you write your ClojureScript, the ClojureScript compiler will take it and transform it into JavaScript, and it uses the Google Clojure compiler to do this. So in the end, you will have highly optimized JavaScript code from your written ClojureScript code. It's really neat. It borders on magic, if you ask me. It is, it makes your mind boggle, really. What is really nice is that you have one single syntax that you need to worry about, Clojure, the Lisp syntax, which is really nice, concise, does not have the overhead of object-oriented programming languages like Java, in which you have a lot of boilerplate code. So it is just it's insane. It's insanely nice. In the project file, we will add a minimum Leiningen version requirement. I put 2.5.3 in because I always put that in, and the current 2.6.1 already. Let's just say 2.6.1 then. Why not? So it is mostly up to date. One thing that we want is to have a main directive in which we want to skip all the optimizations so that we can have a running system called trivia.core. We will create the file in a little bit. Now we'll have a target directory, a target path really, called target. And because we created multiple source directories, one for Clojure, one for ClojureScript, we need to tell Leiningen that we have that. And we will say we will have a source Clojure and a source ClojureScript, and those will be really used for finding compilable files. We will also do test. We will be very good programmers and start with test code as well. So we will have test Clojure. Let's create that directory immediately. Make the test -p for the path, test Clojure, so we don't need to make each file directory separately. Let's see, do we need some more stuff? Since we use ClojureScript as well, we will need to add some clean targets. Clean targets basically allows us to protect or do not protect files from cleanup. And because we generate JavaScript, and that JavaScript needs to go into our web root, and our web root also contains files which we get externally, for instance Bootstrap or jQuery, we need to tell Leiningen to specifically clean up those files and not anything else. So we will start with resources public JS compiled, because we will tell Leiningen to dump everything there. We will want to clean up our target directory, in which our normal ClojureScript Clojure to Java translation takes place, the compilation, and we'll have some test.js files. Why not? All right. And just to get ahead of ourselves, we will have a Figwheel. Figwheel, if ClojureScript is bordering on the magic part, Figwheel is pure magic. Let me type this out first. Resources, public, CSS. We will instruct Figwheel where it can find CSS files. I don't think it's necessary at this moment. We will leave that. Figwheel is pure magic. We will get to it in a little bit. We will first create some profiles which tell Leiningen what kind of builds we want. So the first one is a uberjar, and an uberjar basically says compile my Clojure code, compile it to Java objects byte system. It will compile it, it will be very nice, and it will put it in a jar file. And if you copy just that jar file and you try to run it on your on another system, if you have any form of dependencies, it will fail miserably. And uberjar will create a jar file which contains all the dependencies that you need. So you can move one file over from one system to another system and run your exact same program there. So highly necessary. Especially when we go to the Docker part, and when you want to test your software with Docker, you can just run it and have an isolated system, and you don't need to worry about dependencies. In the dev profile, which is where we normally spend our time, we can add some extra dependencies, and we will add some that we need for Figwheel. Figwheel sidecar 0547. I've just read them from my other project file because else I cannot remember it. Comes Summaric. The piggyback. Strangely enough, if you create a project from a skeleton, generally they forget the piggyback library, which is needed when you run from the nREPL that Cider uses. It will not work really nice unless you have that piggyback library. And in the browser, in order to binary H, to instruct Chrome, or to enhance Chrome really, 080. We can have some custom formatters which allows us to look at our ClojureScript code and objects within the Chrome browser. So that's this beautiful library, and we only need it during development, so hence we put it in here. And here we will add our friend Figwheel. Figwheel 0547, and there's a really cool testing library for JavaScript called Do, which is really nice. It allows us to write Clojure test or ClojureScript test code within our project and have it executed on various browser platforms, so Chrome, Firefox, or what you want. I don't know if it does IE, I'm not sure, but it's very good, it's very nice. Let's see. I'm wondering if we're still live. My stream froze up. Well, according to the OBS Studio, it still works. But who knows? Huh? Yes, we're live. Killed the sound. That looks good. Very good. All right. Seems we're still live. Okay. Well, next thing we do, we instruct the build system to just allow for ClojureScript builds, and the first build that we will add is a dev build. ID dev source paths source ClojureScript. Figwheel, we will have a directive for it. On JS loads, we will run trivia.core mount roots. It's tightly coupled to the reagent library that we're going to use. Now for some compiler instructions. Normally you just generate this file from a template. Not many templates have a really good, concise view of the world. They're focused on just their library or their platform. So I like to just type it in. Trivia core is the main. I'm gonna output 2. Well, and here we go. So the resources library that we already have, public JS, compiled, just called app.js. Outputs there. It's pretty much the same. Except we do out, and it will put all the dependencies, everything that we need, everything that our application needs from the ClojureScript compiler cycle into that directory. Asset path JS compiled out, and yes, we will not do that yet. And source map timestamp. Have a timestamp on our source map, and we're done with our build configuration. So what we set up now was the dependencies for Clojure and ClojureScript, a plugin for Leiningen which allows us to have a build system for ClojureScript. We set it to the minimum version of the one that we have. We told Leiningen that our main code entry point is trivia.core. This is for the Clojure part of the world. We'll have a target path of targets. Well, we set up the sources and the test location. We told it what we want to clean up, and specifically what not then really. We added a profile for our endgame, our all-encompassing Java jar, and we set up a build environment, basically development environment, which has additional dependencies and some plugins. And we told the ClojureScript compiler that we currently only have a dev setup, and that we instructed to put their files somewhere. In this case, resource public. So the theory is that we can now just start Cider and have a project. We just typed everything in, so we probably failed miserably. So let's see. We will start it. See, we failed miserably. Messages. What did we do? As file closure, Java corrections. We missed somewhere. description, URL, it's fine. License looks fine. Dependencies, Clojure, ClojureScript. We had an array for plugin or list minimum lane version. We had a main skip AOT, target, source, clean targets. And some profiles, UberJar, AOT, dev dependencies, plugins, ClojureScript build. So let's just comment out some parts. Start with the smallest version. Boom, 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 boom. The start of the nREPL is the most time-consuming thing in the world. It starts JVM, then it starts the Clojure interpreter. The Clojure interpreter reads code. See, that worked. We'll close it down. So we made a boo-boo somewhere. Let's see. I'm guessing we did it somewhere around here. Somewhere around here. Boom, boom. It's debugging old school style, just commenting out code until it works. I think we made a typo here. Or I made a typo, you just watched. You watched me do it. We have sort paths. See what it does now. That looks good. So only thing we need to fix is the ClojureScript build in the bottom. Could not find sidecar. Okay. So I probably made a typo. Figwheel sidecar. Oh yeah, see, I made a typo. That's fine. Cannot find something, that's fine, as long as you do the things you're supposed to do. So let's just kick off everything, live dangerously, why not? Boom, 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 boom. Still the sidecar, why is the sidecar? I must have made a typo. Fig, yes. Typing, some people do it very well and without any form of error, but not me. No. See what YouTube thinks about everything. Beautiful. Beautiful. So we have, as you can see, we have the nREPLs, they start. They tell you I am running on Java version, on Clojure version, and here it has a Clojure and Java version. So it seems to be the same thing, except for this part. This part says this CIDR REPL is for ClojureScript, and this REPL is just for Clojure. And now it will fail miserably because there's no namespace trivia core. Could not find it, blah blah blah. And we told it that the main part of our, if we take a look at the project, the Figwheel on load, it should do the trivia core mount root. And I'm thinking, if I look at my Emacs configuration, Figwheel, the Figwheel do use that, yeah, so that only listens to the configuration that is here. So it says trivia core mount root, what is this? And it says trivia core, what is that? I don't know, there's no file. So that is of course very true, because we told it it was there, but in actuality we lied. The system will get over it, but we did. So let's start with trivia/core.clojure, make directory. Very good. So the basic Clojure file layout and namespace trivia core, and we will just create a main that does not a lot of things. We will add many cool things, but we, yeah, that was the door. Start the application. Takes many arguments, but they're all optional. And what shall we do? We will just print line hello world. That's the part that we will do for now. And what that does, when we would run it, it would print hello. So we executed it in the buffer, and in the REPL it shows the hello world, which is very nice. It is beautiful. And then from the ClojureScript side, we will need to do a little bit trivia core.clj. Same thing, does not exist, create, yes, thank you very much. And we will create a beautiful web application, but the, what we want to use is the React or framework, which is JavaScript only. It has a ClojureScript implementation called Reagent. And Reagent is really nice. It allows you to have nicely reactive web applications using React. They're blazingly fast. They're amazing. And so we're going to add the library for it. And one of the nice things that we want to have is the library to our system, but we don't want to restart the system the REPLs every single time. So we're going to hotload the artifact reagent, and we want 06 RC. And we'll add it to our system. Clojure will do its thing. And what that has done, if we go back to our project, it will have added reagent as a dependency, and that will allow us to add reagent core as reagent. Now we have added it to our namespace and we can use it. And the one thing that we want to do, we had this, if we go back to our project file, we told Figwheel that when it should load, when it loads the page that we're interested in, we'll go to trivia core, the namespace, and in which we are now, and then it will call the mount root method function. So we'll just define it, mount root, and it will take 0 arguments, and it is actually a reagent call. And we want to render. We'll have some views. We should add the view here, but let's just do h1. Maybe this will work. I don't know. We'll find out. And we will do that. It's by calling the get element by ID on the JavaScript document. Get element by ID on the JavaScript document. And we will have an app div from which we will load this magical application. So what is this app div? Well, that's basically just a div in a HTML file, and that HTML file we have put in resources public, but we did not do that yet, so we will need to create it. And let's create an init function, which actually calls mount root. Let's see, we have, and this init function we will call from our it's not this. Ooh, I see what's going on. Since we started the cider REPLs from an empty project, it is getting confused. So I killed everything now, because it did did the hot loading, but the Figwheel session could not connect, so it's running and running and running, and the REPL hangs from that. So we did that to ourselves, or I did it to myself, and to do that we will just fix it by killing it. We just said that we need a index HTML, and I for one do not like to type HTML code. I think nobody does, so we will just copy it from a different location. Resources public index.html. Bam, we have a lot of stuff now. We'll just remove this part already, and we will tell it the following thing. So we have a div for the application, the one that we used on ClojureScript core here. We told it that there would be in the JavaScript document, if we get element by ID app, we will get something in which we will render this magical component. I wonder if the H1 works. We will see. And the init function basically calls the mount root. The mount root calls the render. The render will pick up the app div and add this content, theoretically. The app div is here. The HTML file will load the JS compiled app project.js, which looks like this, which is a lot of Google Clojure code, which is wonderful. It loads it, and then trivia core init will be loaded. So if we try to find our trivia core JS, it looks like this. It does very little because it started to hang before we could really add functionality to it. So we have that JavaScript being generated, loaded into the HTML. We have our ClojureScript here, so let's restart the REPL. So now it should just boot cleanly. It will find the root function here. It will have a file to load, and that will mean that we can load up the REPL, the Figwheel live reloading REPL thing into our browser, and we will be a happy camper. How long have we been going? I lost track of time. Oh, 41 minutes. Wow. Time flies. So what we see here now, it started the REPL. It's watching the build dev, clean build dev, compiling into the app.js. It compiled it. There is an auto build going, and the prompt will show when Figwheel connects to your application. Well, since it is running, we should be able to just load it up. It says hello, and now you see that the Figwheel hands back control to the REPL, but it is REPLed into a ClojureScript.user namespace, which basically means that if we add the ClojureScript REPL here, any command that we do here will basically be transported to the browser session next to it. So if we do a JS alert hello world, we should have a pop-up. Bam, that says hello world, which is a pop-up for the browser that we're connected to. So basically we are, in a sense, editing code which is live running on the browser in this window. If we open up the development console, the dev tools that we also added, we see that Figwheel did a lot of things. It loaded the library. And one important thing to remember whenever you do ClojureScript code, and to ensure that everything is loaded correctly, you need to require it. And even if you do not use it but need to have it implicitly through some other means, don't forget to require it, because it will give you headaches. So if we add a method, and we would say we change h1 here, hello world. Did you see that? There's a green ClojureScript icon, which will go green if you did it correctly, and it will let's see, get element by ID will fail. Yes. If it fails to compile, it will tell you exactly what failed to compile, the warning, where it is, line 6. There's some really nice explanation of what you did wrong. It's programming nirvana. Basically, bam, it's all fine. It is reloaded. If you add something, it live reloads. The reframe framework that we will use for the application rendering will be much more mind-blowing than this. But what we did now is that we have code which is being built in our project. We have some Clojure code being compiled into bytecode in the Java REPL, or inside a REPL on the Java runtime. We have ClojureScript code which we added, which basically loads a HTML file, which creates a single page application which says hello world. It's not very exciting at this moment, but it is running. We can do live development. This is perfect. So let's do let's write some tests at this moment as well, just because so we can show it off. So we do some test Clojure, trivia core test Clojure. Would it be like this? Yes. So it says, yes, create directory. So when you create a test, basically a namespace should be countered with a namespace with a minus test name. It seems to be the convention, and it allows us to say, okay, if we take a look at the core.clojure, then for instance, that we create a method that says A and B, and we do A and B. We add them, we eval it, so now in the namespace trivia core, it will have an add method, and we can call it add 1 and 2, and it will tell us 3. It's beautiful. And Clojure is very concise, same as ClojureScript, but that means that you can easily test small parts and ensure that everything works correctly. It makes testing quite easy, and we will use the dev test. I forget how it's called. Testing. I forget it. Clojure test, dev test. Something like testing. Oh, it's almost there. Almost there. Testing ads. And then we do the is. And we know that the system under test has an add. Why is my... Oh, interesting. There we go. Has an add function, and if you look below here, my Emacs tells me that add takes 2 arguments, A and B, 1 and 2, and the result of this should be 3. So if we do this, it tells me it's 3. If we do equal, it tells me it's true. If we do is, it tells me it's correct. And dev test, it says, oh, I evaluated. And now it allows me to tell CIDR to ask CIDR to CIDR interactions test to run the tests, which is mapped to Ctrl+C, T. So that's Ctrl+C, and if we see here, there's a comma. Where is it? CIDR test run test. That's my own method. Where's the comma? There's more pages. Next page. Comma T. It runs. It tells us there's one assertion in one test function. There's 0 failures, 0 errors. If we run it on, we can run it on the command line as well, which is really nice for. Ooh. Core add. Did we add numbers? Is there a method that we just shout out? That is interesting. So in our test, we shadowed a function in the probably in the Clojure runtime. So we should not use these type of things. It's a horrible thing. I did that. That was my bad. So at least it tells us we ran it. We did the core part. We did the one test, one assertion, and it's fine. So let's just leave it in there. We'll imagine that this add numbers is something that is part of our project, and we have something that can run into continuous integration and ensure that everything works nicely. So the same should work. ClojureScript, trivia, core test.cljs. Yes, we will make them underscores. We will create them. We found the primary. So there should be the dev test testing ClojureScript. And just for the fun of it, we will add into the ClojureScript core, we will add the same exact method that can add numbers A and B, and we will result in A and B. We will evaluate. This means that if we do add numbers 1 and 2, it should give us 3. That is very good. And remember, this is running in the browser, which is really nice. So we can ensure that the system under test adds numbers 1 and 2 equals 3. System under test. That's interesting. Why is that not doing it? Maybe I made a boo-boo. Did I make a boo-boo? There, I made a boo-boo somewhere. I think in the namespace declaration I accidentally added a dot. Oh. Very interesting. Stuff happens live. You make mistakes live. So 3 and 3 equals 3 is true. T true. And now for the fun thing. So there's we added the lane do, and then we want to ask phantom.js to test it. Is that the syntax? Nope. Nope. I made boo-boo. I have in GitLab CI. No. So we will look up lane do. Lane do. Spencer do. Lane do builds. So is that then def? The given alias phantom did not resolve to any runners. Do we have phantom.js? -v? Yes, we have phantom.js. Phantom.js. What happens if we just do this? Phantom. Let's not call our directive the name of the products. So there we see it. The Phantom is running the ClojureScript. Did you forget to specify asset paths? I did not so. Not find. So this is looking really bad. Let's see what happens. Not load main. Interesting. Projects. seems we have the asset paths and everything here. And I'm guessing it will need a different build. Build. Let's take a look at my reference project. Yes. So back to the project file. Since we're running it, we'll add an ID test here. And the source, there's paths would be source ClojureScript and test ClojureScript. And the compiler needs some instructions. Output to resources public JS compiled test.js, so we have it separated from the rest. The main will be trivia.runner, so we need to create that, and optimizations. We now have cider running, so we have some enhancements. What is this runner? Sometimes you just build things and then afterwards you forget. That's why it is good. Take a look. Yes, all right. So the runner is a namespace that we will use for basically our we will use it to explain to again the I don't know. Excuse me. The runner will tell Leiningen what test cases to run. So what we need to do is we add a require that says do the runner, and we will get this on refer macros and do tests. We'll execute that. Very good. So that will allow us to have do tests, and the one that we want is nice. So we did something bad. It thinks that we did something bad. So let's you're in error. I understand. Why do that? Why is it so upset about this? Did we forget something again? Okay, we will just kill the repels now, because it will keep haunting us. Trivia core test, and that is this library. So it tells do to run tests, and those tests are defined here. So it will run the trivia core test namespace, and in that trivia core test namespace we have these tests defined, and from there it will run nicely if all is well. So let's give that a try. Let's give it another go. Let's see what it does. I probably should add test for it. Go away. because we created a different profile for it, right? So that looks a lot better. Use init function. Undefined is not an object. Evaluate the trivia core test in ClojureScript. This init function was not set. That is interesting. So why was that not set? And, I would guess it is something in the project file that we missed. Let's take a look at my lane doom. Main, it should be fine. Should be fine. That's very interesting. Why would it not work? Let's kick off the REPL again. Maybe we have a incompatibility somewhere. Let's see what the documentation says in it. So it says do this build, watch mode, can be any of, oh, it does IE, that's really cool. So you can test your JavaScript code or ClojureScript code against IE, which is really nice. We have the main runner, so we do this, we did all this. Does not do anything. So let's see. Look at the projects and ID of test. We had source paths, compiler, output to certain file. The main was our runner. We had no optimizations. Where you define it using. And here's our runner. So we had do runner, refer markers, do tests, and do tests, trivia, core test. You just see it does not like it. No such namespace, do runner. It seems as if the REPL is not getting REPL is not getting it. Oh, my window is blowing out. One moment. The wind is picking up, and interesting. I will need to take a look at it. Well, what can we do? What can we do? Test. Is it just would Slimer work? I don't know. No, does not work. How about this then? Firefox. Let's see what happens. This time, point in time, I'm just reaching for straws, right? Chrome. Ooh. I don't think I did something really, really bad. Oh well, I will go and figure it out and I will get back to you next time on that. For now, I want to continue and add continuous integration on GitLab. And then we'll call it a day wrap for today. And then next week, I will, in the meantime, I will figure out what went wrong. So probably something really dumb. We'll find out. All right. So if you have any type of project, anything, you should have a Git repository for it. It will save your life many, many times over. So if we take a look at the Emacs here, we'll create a Git repository under Clojure trivia, which is fine. We'll create it. We will add some files to it. We will ignore lane failures. We'll ignore the nREPL port. Ignore the log file. Ignore the output directory. /out. What did it do? There we go. Modified new file. We will stage the project file. Resources. Public JS compiled. We need to ignore this part because we do not want to have our compiled code in the repository. So we'll go to the ignore file, git ignore, and we will add this one. And if all is well, if I stage it, it should have our index.html. Yes, we did it correctly. We can ignore the target directory. Target. We can better just add it. Sometimes it works really nice. I don't know about this console mode in which you cannot really flip around. It's more of an Emacs thing that I'm not sure if it is a good idea to have it, but I'm using it. So we have staged all the files. We have to git ignore the project, resources, the source files, and the test files. We will commit it, add our build system. So for now it's committed, but it's only locally. We should put it somewhere. Many people use GitHub. I also have a GitHub repository, but I like GitLab a little bit better, basically because they're more focused on the entire development cycle, I think. So you not only have repository, but you can. They also have a built-in continuous integration system, a registry for Docker instances that are your own. So you can have your own Docker systems. So let's create a new project. We will call it Trivia. So build fun things Trivia. We're not going to import it. I will make it public so that you can grab the sources. Do the create. Wait a little bit. Whoop. So we have a nice repository. It is empty, which is to be expected. We created our own system already. So all we need to do is push this code to the repository, and that is done via a remote. So if we look at Magit, it will tell us that remoting is M. We can add a remote name, or we call it GitLab. That allows us to also add more, like GitHub or any form. GitLab, we will tell it. Set remote push default to GitLab, yes. That way we will have any push. And it says the push, the master is missing, so we will push it real good. And Git will be pushing at our build system, and at this time we should have a beautiful, beautiful repository. It's very bare, it misses the README, the license, and those type of things, but for now it is working. But what we want to do now is that we want to make sure that every time we do a check-in, it is independently verified that it is working. And that is done through a continuous integration system. And luckily GitLab has this. So we can do builds, and basically GitLab just does this automatically for us once you create a GitLab CI YAML file. So let's add that to our project GitLab CI.yaml. Right. All right. So what should we do? We should create a Linux distribution that has a Java compiler onto it, which grabs Leiningen and then runs Leiningen on our project, builds it, runs our tests. So if you remember, if we clean up this mess and say, if you remember, and we do a line test, it should say, it runs, it should say all is well. And once we have the ClojureScript do runner thing sorted out, it should also run there and allow us to see a very nice picture of our code. If we create test cases for the code that we write, we are sure that everything is fine once we check it. So the way we do that is by saying before script, maybe we have a YAML mode. YAML. There is list packages for Emacs. YAML mode. We want this one. We want to have the ability to, yes, save it. Beautiful. We want YAML mode. Beautiful. And YAML mode says, GitLab basically says you will get a Ubuntu machine, a Debian or Ubuntu based machine from me. So what we do is we do apt-get update -y, so we are sure that everything is up to date. Apt-get install the default JRE -y. That's all we need because the compilation takes place in the Clojure code, and Leiningen takes care of it. Now there's this really good way to get Leiningen, and that is by getting the stable version from GitHub. We will need to make that executable, and very important within Docker, we need to tell Leiningen that it is okay for it to run as the root user. Normally it will not allow this, so it is a good thing that we can override it, because else it would be quite useless in a Docker environment. We will add the current path to the current location to the path, and we will have Leiningen grab the dependencies. So at this point, the Docker instance will have Leiningen installed, it will have a JRE, so everything will work, and dependencies for our project, which were Clojure and ClojureScript, the Leiningen do, ClojureScript build, all those things will be downloaded for us. So in order to then do stuff, we will go into the test area, and there's a script, and our script will basically be Leiningen do überjar, which is a thing that we want, and well, Cloveridge, basically überjar and test. That's what we want. We wanted to do, no, we want to create a jar which has everything into it, and we will grab that asset from the system, and we will want to have it run a test, and if all that is run correctly, it will be fine, and our build will succeed. So we will have artifacts, and we can have many artifacts. And the first thing that we'll have is a target überjar star.stand alone. We did not even test this. We we assumed that it would just work, or I did. So if we take a look at Leiningen überjar, if we run it, oh, that's interesting. Core. When the Clojure compiler creates the bytecode for the in its compile cycle, it will create classes. It will make that as efficient as possible for the computer, but sometimes you need to refer to methods of a class directly, as we did in the project. We told it that trivia core was the main function. We created a main function, but if the Clojure compiler does its thing, the thing will not be called trivia core. So we need to add the gen class directive, and it will create a class named trivia core with a method called main. So when Leiningen or the jar calls it, like this, target überjar trivia standalone jar, it should say hello world. It does hello world, and it can do that because it can now reference by name trivia core dot main. So we forgot the gen class. That gave us a little bit of headache. So we want that jar, which is basically this path, and that will allow us to run hello world on a system. So if we have all this, this should be fine. Let's add it, we stage it to fix our core. We will commit it, add GitLab CI correct gen class for core. There we go. It will tell us it's unpushed. We will push it to the system. And what we should see now, if all is well, we look at our project, it now has this thing, it says pending. Pending and waiting for the build to be done. So if we look at the repository, we now have we're looking at the pipeline. Look at this pipeline, much better view. We have one task running. If we look at this task, it is running at this moment. They changed it again, very nice. So if we look at the actual thing that is happening, The GitLab CI multi-runner is running using Docker with the image Ruby 2.1. So we can now sit back and look at what's going. As you can see, it's running Debian Jessie, and it's doing updates. It's basically the update -y which is going on now. Now it's going to install the default JRE and it will accept everything. So you see that going on. It's going to do the OpenJDK7, as you can see. Ooh, might need to change that later on to the 8. Many things to do, and we don't have to do them. We can just watch. It's good. So we have the OpenJDK7 headless. It will update the alternatives. Blah 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 blah. So what you should do now is get the Leiningen. Oh, we are already there. So it retrieved Leiningen, it made it executable and does Leiningen deps. And now you see a lot of jars being downloaded. These are all the things the system needs. Boop. I think it's finished. Let's scroll all the way down. Normally don't look at it, just look at the result, right? So it has all the deps. Do uberjar test, compiling, create an uberjar, the test one assertion, uploading artifacts, fund one matching, build success. Yay, we can party like it's 1999. You see it's passed now. If you look at the pipelines, we had one build, this is the latest, it is beautiful. And we should, this is the diff that we have. We should have some artifacts now as well. Let's see where they are. This CI configuration that we already know. Where did our... It's my cat who likes to talk. Where did our artifacts go? We have the pipeline. Pipeline, test passed. Build details, build artifacts, there we go. So there's this one uberjar that we added. Once we have the code coverage and everything, we will add that as well. So we can provide these for download, for instance, if you wanted to. So what did we do? We created our Leiningen project. If we go back to our schedule, we created our Leiningen project for ClojureScript. We had our Figwheel integration. We did our GitLab project, GitLab CI. Did not do the Docker one yet. I will move that to next week because we've been going on for about an hour now, I think. 1 hour indeed. I want to cap it at that. I will edit this video into a shorter video which will be published on YouTube as well on buildfunthings.com to have a more concise view of it. So I hope you enjoyed it. I hope you learned something, and I will see you again next week.